this video, we're going to be talking about how do we perform operations with fractions. So there's always a lot of misconceptions that happen with fractions, and that fractions are hard, but they're actually pretty easy, and they're actually a little bit easier to work with than decimals. So if you have a good understanding of what it means to be a fraction and how to manipulate them, they're actually pretty easy to work with. So first, let's talk about what it means to be an equivalent fraction. So an equivalent fractions are fractions that they may look different, but they're actually simplified to the same number. All right, so in order to change the denominator but not change the number, you must multiply or divide the numerator and the denominator by the same number. So this is how we can make equivalent fractions. So in this first example, we're trying to write a fraction that's equivalent to 3/6. So it needs to be equal to this, but it needs to have a denominator of 2. So on my denominator right here, which is the bottom piece of the fraction, it needs to have a 2. So what did I do to get from 6 to 2? Well, I divided this by 3. So now you can't just take a number and divide it by 3. That's changing the quantity of it. So you can't just keep this a 3 on the top. You're making a complete different number that's not equivalent to 3/6. So what you need to do is you need to multiply the top and the bottom by 3, because this is technically what you're doing is you're dividing by 3/3. And what number is 3/3? Yes, it's 1. Now 3 divided by 3 is 1, and so 1/2 in 3/6 are actually the same number. There's just two different ways to write the same thing. Okay, so we're done with the first example, and now the second example, we need to write a fraction that's equivalent to 5. We're going to be using this skill a lot in the future, with a denominator of 10. So it needs to have a 10 in my denominator. Now, what's the denominator of a whole number? Well, yes, it always has this 1 on the denominator, but we don't need to write it because it's kind of understood that this is 5/1. You have 5 whole pieces. You do not need to write that 1 on the bottom. But for right now, we're going to write it so that we can see, well, what did I multiply by to get a 10? Well, I multiplied the denominator by 10. And so remember, we need to multiply by 10/10 so that we don't change what the value is. So that means the numerator also needs to be multiplied by 10, and this becomes 50. So 50 out of 10 is the same thing as 5/1. It's just two different ways to write this. Okay, so now we're going to be using that skill a lot to add and subtract, because when I'm adding and subtracting, what I want to do is I want to create the same size pieces, right? So that I can go ahead and put them together, right? If I just don't make them the same pieces, then it doesn't really make sense, right? So for example, if I have like 1/3 and 3/2, let's say 5, and I just say 4/7, well, that doesn't really make sense because I didn't make the pieces the same. So that is not a correct way to do this. Okay, what we want to do instead is we want to rewrite as equivalent fractions that have the same denominator. And then we can add and subtract the numerator, because the denominator tells us like the size of the pieces, right? We add and subtract the numerator, and the denominator is going to stay the same. And I always say when you have your final answer, just go ahead and simplify it if possible. So let's try a couple of examples here. So I have 4/5 plus 3, 10. So if I'm looking at my denominators, well, what's the least common multiple between them? Well, it's going to be 10. So what we're going to do is we're going to make this 4/5 into an equivalent fraction. Remember, we can't change the value of the fraction, but it does need to have a denominator of 10. So on this denominator, that means I would need to multiply it by 2. And so I'm going to multiply my fraction by 2/2 so that I am not changing the value of this guy right here. So you're going to get 8 on your numerator and 10 on your denominator. And we're adding this to 3 tenths. So great. 8 tenths and 4 fifths are to the same number. Perfect. But now I have something where my pieces are divided into 10. So now I can put these together and tell you how much out of 10 I have. So 8 plus 3 is going to be 11 over 10. And then at this point, a lot of people say, well, can I write that as a mixed number, as 1 and 1/10? Well, for the purpose of this class, we will not be using mixed numbers a lot. We're just going to be using 11 over 10. So improper fractions are good here. You can leave this as 1 over 10. 11 over 10. Okay, so this next here, 7 and 3, our least common multiple, you should be thinking about that in your head, is, yes, 21. So here I need to multiply this by 3 over 3. And then here I need to multiply this by 7 over 7. So my first fraction becomes 9 over 21. Again, 9 over 21 and 3 over 7 are the same number. They're just different ways to write that. And I need the 9 over 21 so that I can combine it to this fraction here. So 5 times 7 is going to be 35 over 21. Now we can go ahead and we can add up these numbers. And we're going to get 44 over 21. And so now, we would think to ourselves, can I simplify this? Well, no number goes into 44 and 21, so that's it. We would be done in this case. Now, 1/4 and 1. This one should be a little bit simple. Again, we're trying to think to ourselves, how do I make 1 into a number that has a denominator of 4? And so that's a pretty... not that difficult of a question. If you don't know, right, we would do the same steps we were doing before, times 4 times 4. But really, you should think 4 fourths. This is a whole. This is one whole number. Great. Now I can add it to 1/4, and I'm going to get 5 fourths. And again, this doesn't simplify, so we're done. Okay, now let's talk about multiplying. Okay, so multiplying is something that a lot of students, they come in and they know how to do it, but they do it the hard way. So we're going to talk about how we can go ahead and do this a little bit easier. So first of all, you can multiply fractions that have any denominator. So we don't need a common denominator here because we're not trying to put them together. We're just trying to multiply them by each other. So what we're going to do is we're going to divide or simplify. Actually, most accurately should say simplify opposite numerators and denominators. And I'll explain that in the next example, but just write this down in your notes for a second. With what is left, you multiply the numerator with the numerator and the denominator. Wait, the numerator and the numerator. So not. And the denominator with the denominator. So a lot of students come in knowing the step 2 and step 3. And they make their numbers ridiculous, and then they try to simplify. And of course, if you can do this, all power to you. But my idea is, well, why don't you simplify your numbers first? And then go ahead and multiply. That's going to make your job a lot easier because then you don't have to simplify at the end. You've already done that in the beginning. All right, so let's kind of look at this. So here I have 21 over 2 that doesn't simplify and 10 over 3 that doesn't simplify. Now, we're going to go ahead and multiply this, but we're going to simplify our answers first. So the nice thing about multiplication is that, right, we were going to do 21 times 10 and 2 times 3, is that a multiplication is commutative. So 21 times 10 is the same thing as 10 times 21. So I can go ahead and flip my numerators. And in this case, I would have 10 first and then 21 second. And then you can keep your denominators where they're at. And what's nice is that 10 does simplify, 10 over 2, and 21 over 3 does simplify. And this is what you would have done to simplify at the end anyways. So what we're going to do is we're going to simplify that first by looking at our opposite numerators and denominators and simplifying those first. So 21 over 3 is going to simplify to 7 over 1. And 10 over 2 simplifies, well, what number goes into 10 and 2? Well, 2, right? Simplifies to 5 over 1. So now our problem is 7 over 1 times 5 over 1, which is just, well, 7 times 5, right? I'm going to do my numerator is 35. And 1 times 1 is 1. Again, it's over 1, which I don't need to write. So my answer here is just 35. Let's try it again. So here what I have is 1 over 15 times 5 over 2. 1 over 2 doesn't simplify, but 5 over 15 does, because 5 goes into 5 once, and 5 goes into 15 3 times. So this is really the fraction 1/3. And now I can go ahead and multiply 1 times 1, which is 1, and 3 times 2, which is 6. So this simplifies to 1/6. Of course, you could have done 5 over 30, but 5 over 30 is the same thing as 1 over 6, and it would just have been a little bit harder to simplify that. Well, let's try it here. 1/4 times 8, this is a whole number, right? So I can put it over 1. And so 8 over 4 is going to simplify to 2. And 1 over 1 is just 1 again. And so really what I have here is 1 times 2, which is 2. Great. Now let's talk about dividing. So just like multiplication, you can divide fractions with any denominator. So they can be any size pieces. Now, what we're going to do is we're actually going to create our problem and make it into a multiplication problem. So I just want you to think about, look, let's suppose that we were doing 300 divided by 10. Again, this is an easier problem, which I'm sure you can do. Well, this is the same thing as saying 300 times 1 over 10, right? I would figure out, right, if I was doing my multiplication here, 300 divided by 10, right? It goes in 30 times, and 30 times 1 is 30. And so 300 divided by 10, again, same idea. It's the same exact problem. Well, this is what's nice. If I am dividing by a number, well, it's the same thing as multiplying by the reciprocal. So what we're going to do is, let's suppose that we have 300 divided by 1/5. Well, instead of trying to figure out how many times 1/5 goes into 300, which is a lot, what we're going to do is we're going to multiply 300 by its reciprocal. Well, the reciprocal of 1/5 is 5 over 1, which is 5. And we would get, it's the same exact thing. We're just changing this into something that's easier, but that we already know how to do. So the process of this is called keep, change, flip. So we keep the first fraction. So the first fraction is what you're dividing, and that stays exactly the same. We're going to change our problem from division to multiplication. And we're going to flip the second fraction. Or in other words, make it into a reciprocal. All right, so let's try it. Okay, so 2/3 divided by 5/3. I'm going to change this problem into a multiplication by, instead of dividing by 5/3, I'm going to multiply by its reciprocal, which is 3/5. And then now we're going to use our multiplication things that we learned. So 2 over 5 doesn't simplify, but 3 over 3 does. It simplifies to 1 over 1. And so now this is really 2 times 1, which is 2, and 1 times 5, which is 5. Okay, now here I have 7/10. Instead of dividing by 3/4, I'm going to multiply by 4/3. And so this here simplifies to 5 and 2, because 2 goes into both of these numbers, right? It goes into 10 5 times, and it goes into 4 twice. And then now I can multiply this. 7 times 2 is 14, and 5 times 3 is 15. So this is just 14 over 15. And then the last example here, I have 1/4. Well, 1/4 is going to stay exactly the same. And I'm going to multiply this instead by its reciprocal, which is 1/6. So here nothing simplifies. So I'm just going to do 1 times 1, which is 1, and 4 times 6, which is 24. So it's 1 over 24. So that is the end of this video, and I hope you found this very useful and insightful on how to work with fractions effectively.